Hello, my friends. Welcome back. So now we are at the point of chapter 1 where we're going to talk about units of measurement that are associated with data, with numbers that you will deal with in the lab and in lecture. Specifically, we're going to spend a lot of time doing some problems here in subsequent videos as well as in lecture. We're going to spend some time using dimensional analysis to solve problems involving measurements. And throughout the course, throughout my lectures, I'm going to have these big stars. Those are reminders to me to remind you that this is a concept that is particularly important. It's particularly vital that you master this skill of dimensional analysis because you're going to be using it throughout this course. Maybe not necessarily with gallons and liters or units that we generally use in everyday life, but you'll be using dimensional analysis skills with balanced chemical equations and doing calculations with them. But before we get to balanced chemical equations, let's talk about units associated with measurement as well as doing calculations with this topic called dimensional analysis. So I always start out this part of the lecture in intro and in Chem 1 with this picture of my son, who's now actually a lot taller. He towers over me now. But I like this picture because it does a good job, I think, of illustrating the point about measurements, that all measurements, be it height, weight, mass, volume, all measurements have three important things. They have a sign, usually they're positive, but there's going to be some measurements you deal with in lab that are negative. Obviously, they have a number associated with them and a unit. And that unit is almost just as important as the number because the unit that comes with the measurement says something about what is being measured or what is being communicated. So this is actually a picture of my son at the Mint in DC. If I was to tell you from this picture that my son Christopher is approximately 1,444,600 tall, you'd probably look at me and say, what do you mean, Mrs. Lipola? How can anyone be that tall? Well, I mean, according to this, he's about that tall, according to this scale. And so that's where the importance of the unit comes into play. A unit says not only what are you measuring, but it also gives the scientist or the person that has the data a scale that is being used to express that measurement. In this case, my son Chris is approximately 1,444,600 bills tall in $100 bill notes. So if you stacked $100 bill notes from floor to ceiling where he is, it would be approximately that much money. Now, when I tell you that scale, you're like, oh yeah, that makes sense. The point of this, aside from being able to show off a picture of my son when he was still little, is that units are really important when recording measurements in the lab, when doing problems in lecture. And I'm going to be looking to make sure that when you write down measurements or do calculations that your measurements have not only the number, but the unit associated with them. So that's the first point. The second point from this slide is when we talk about a measurement, all measurements are subject to some sort of error, particularly if it's the first time in lab doing something, right? And so when we talk about a piece of data, we often use these terms accuracy and precision when talking about a measurement. We tend to use them as synonyms, but they actually mean two different things. Accuracy speaks to how close a value is to a known, true, accepted value. Precision deals with the concept of significant figures in a number. And usually at this, and we're going to talk more about significant figures, and it's usually at this point in the lecture that students say, oh, sig figs. I hated sig figs in intro chem or in my high school chemistry. There was no use for them, in my opinion. They give me a headache. Well, hopefully I'm here to, we're going to do some practice with them. I'm not going to be as picky with sig figs toward the latter part of the course as I will be toward the beginning. Hopefully I will give you some rules for sig figs that will help you to organize your thoughts when determining if a number associated with a measurement is significant or not. So hopefully you won't feel like this guy down here. But significant figures speak to the level of precision of a measurement. And we're going to talk about the rules for determining what numbers are significant or not. Okay. Numbers or measurements that have more significant figures are obviously more precise. So for example, if I said something is 1.1 grams versus 1.0001 grams, this measurement has 2 significant figures associated with it versus this one, which is 5. So this second measurement would be more precise. Okay. So you should know the difference between accuracy and precision. Know that precision is conveyed via significant figures in a measurement. And now we're going to talk about the rules for significant figures. And so here, this is a summary of the rules, and usually where students, I think, get the most confused with significant figures and measurements is with the zeros. Because if you have a measurement that has all non-zero numbers, those numbers are always significant. Let me get my little pointer here. So for example, this measurement, 3.34, that number has 3 non-zero numbers, so that number has a total of 3 significant figures. Where it gets a little tricky for students, I think, is the zeros. So there are 2 places where zeros are not significant, and I'll focus on those right now. So zeros that are to the left of the first non-zero sig fig and to the left of a decimal are not significant. That just means, doesn't mean we can drop them, that just means they do not speak to the level of precision of a measurement. So for example, in this measurement, both zeros are not significant because both of these zeros are to the left of the first non-zero sig fig, which in this case is a 2. So this number has a total of 2 significant figures, the 2 and the 3. Okay. Then there are, so in both those cases, the zeros are not significant. Then there is the case of ambiguous zeros. Those are zeros that are in a number that are not associated with a decimal place. So if you see in this rule, we said that zeros are not significant when to the left of a first non-zero sig fig and decimal. What if I was to give you this number 12,000? Well, you'd look at that number and obviously you'd say, let's say I was to ask you the number of significant figures. Well, that 1 and that 2, both of those are non-zero numbers, so both of those are significant. I have these 3 zeros here, but there's no decimal point. And I only know that zeros are significant when to the right of a digit and to the right of a decimal point. This number has this first number, 12,000, has no decimal. So when you have a number that has no decimal with zeros like this, they are called ambiguous zeros, and they are not significant. So this first number, 12,000, only has a total of 2 significant figures. Doesn't mean we can just drop these 3 with respect to writing the number. That just means that those 3 zeros do not speak to the precision of the measurement. So this first number would be something like there were approximately 12,000 birds in the park. Oh, that'd be a lot of park. There'd be a lot of birds. There are approximately 12,000 birds. Let's say you actually went and you counted numbers of tickets. You know there were exactly 12,000. That exact is shown by this decimal point, because now when I have it, which I just covered up here, sorry. Now I've got a decimal point there, and that decimal point tells me, oh yeah, these 3 zeros that are after, or that are to the right of a digit and to the right of a decimal point, those 3 zeros, they are significant by this third rule. This decimal, or this 0 here after the decimal, it's also significant due to this third rule. So while this first number has a grand total of 2 significant figures, all of these numbers, so 1, 2, 3, 4, 5, 6, so this final number here has a total of 6 significant figures. Okay. So there are 2 cases where zeros are not significant when talking about a measurement. Those that are to the left of the decimal, those that are to the left of a first non-zero sig fig, and those that are ambiguous, meaning they're in a number, they're trailing zeros like this, and there is no decimal point. So you should feel comfortable being able to, given a number, and using these rules, being able to identify total number of sig figs and what numbers are significant. In the next video, we're going to talk about how to use those rules when doing calculations.